Question 6.32. In the circuit shown in the figure, V1 is 1.50 volt, V2 is 2.50 volt, R1 is 4 ohm, R2 is 5 ohm. What is the magnitude of current I1 flowing through resistor R1? So here you have a multi-loop circuit and they have given you the values of resistor R1 and R2 as well as the source of EMF V1 and V2. We need to find the magnitude of current flowing through resistor R1. So since we have only one missing quantity, we can apply Kirchhoff loop rule to just one of the loop. And that will be the first loop over here because we need to find current through R1. So I will focus only on the loop that contains R1. Now before we apply Kirchhoff loop rule, let us first show the direction of current. I will show current I1 in this manner. Then I1 will split at junction B into I2 and I3. Now this is the direction of current that I have assumed. If my direction is not same as the actual current direction, then the final answer for I1 will come out to be negative. So if you get a negative answer, that just means that whatever direction we chose in the beginning is not same as the direction of the actual current. So now let's start with Kirchhoff loop rule. I will show the direction of traversing. We will go in clockwise manner. Then let's apply Kirchhoff loop rule to loop A, B, E, F and back to A. When we go from A to B, we are going in the same direction as current I1. So potential drop across R1 will be negative I1, R1. Then from B to E, we first enter the negative terminal of the battery. So we take V2 to be positive. Then when we go from E to F and then from F to A, we are entering the negative terminal of the battery. So we write this as positive V1 equals 0. So let's move this to the other side to solve further. We get V1 plus V2 equals I1 R1. And then I can find I1 by dividing with R1. So V1 plus V2 over R1. Now let's substitute. V1 is 1.50. V2 is 2.50. R1 is 4 ohm. And when you solve this, you get current I1 to be equal to 1 ampere.